It's a great honor to welcome Dr. Venkat Padmnabhan, Managing Director of Microsoft Research India, as our keynote speaker today. Dr. Venkat is a leading figure in the field of networked and mobile systems. After completing his PhD at University of California, Berkeley, he joined Microsoft Research, where he has made lasting contributions both at Redmond Lab and in India. He went on to establish the Mobility Networks and Systems Group at Microsoft Research India, which has been the forefront of impactful innovations. His work has significantly shaped areas such as indoor positioning, smartphone-based sensing, with several of these technologies integrated into Microsoft product and real-world deployments. We are truly honored to have Dr. Venkat with us today to share his insights with us. Stage is yours.
Okay, thank you. This is on? Mic is on, right? Yeah. Okay, thank you. Thank you for the wonderful introduction. Good morning, everyone. I also want to thank Professor Nipun for inviting me, and I do see old friends like Pranav here, others as well. But it's wonderful to see a lot of new faces, young people. I'm going to talk through some themes through research, with a particular focus on societal impact, because I think the workshop is about social good. So I think a lot of the lessons, as you listen, right, they are not tied to just work on social good. It could be any kind of research. We are a small group here, so feel free to interrupt me anytime. You don't have to wait till the end. If you have questions, just raise your hand during the talk. So, when you think of research and impact and so on, and some of you I know are PhD students, maybe master students and so on, you probably are thinking about questions like, okay, what is research? How do you find good problems? What is impact? And how can you actually have impact through research and so on, right? So there are many, many questions on your mind. And I will try to provide some perspectives, but I want to be careful to say I'm not providing answers. The reason is that there's no one right answer. And my perspective is colored by my own personal experience. So it's really a personal opinion, not the opinion of Microsoft or anyone else. And it's no doubt biased, right? It is biased by my own experience and what I have learned. So I think I'll come back to this message at the end. So really, please decide for yourself what works best for you, right? You can listen to everything I'm saying, take what makes sense, and reject other things or rework other things. Here's a set of themes that hopefully I will touch on as I go through my talk, right? So during the talk, I will talk about specific projects and so on, but I want to sort of call out these themes because as you listen to the rest of the talk, hopefully you can connect back to some of these, right? So the first is, there are interesting problems everywhere, especially when you think of AI for social good or societal impact applications. You just have to look around, right? And I'll talk about examples, whether it's traffic or healthcare or education or agriculture or climate. I mean, there are just problems that you live and breathe every day. And so there are interesting problems everywhere. There is this notion of what's called use-inspired research or use-inspired basic research. I'll touch on briefly. Now, a lot of what I say is general, but then what changes with AI? And I think a key point I would say is that AI is sort of infinitely malleable, right? In the old days, software is malleable as well, but you would have to create purpose-built software for a particular, user persona or sort of application in mind. But with AI, you can give it some data and then it can sort of automatically learn to do the new thing, right? So that is really what I think is a game changer. Now, even as we get caught up in technology and AI and so on, let's not forget the humans. I think humans are very important, and hopefully you will see that in a few examples, both positively and negatively. Like what I mean is where we ignored the humans and suffered because of that. The other thing is, if you're really looking to have impact, you want to take your work beyond just the research and the lab, but really go out there, you need partners, you need collaborators. It's very, very hard to do it yourself, right? So really making connections and usually finding collaborators who have complementary skills, right? They may not be a research organization, they may not be an academic organization. They could be a deployment partner, they could be someone who understands the domain, right? It could be a hospital, for example, in the healthcare domain and so on. And finally, it's kind of a bit of an oxymoron, but expect surprises, right? So whether it is challenges that you did not foresee or paths to success that you had not foreseen. You thought you will be doing this, but you ended up doing something different, but that turned out to be just as good or even better, right? So that is something that hopefully you will also see through some of these. So let's talk about just briefly about research, or at least the way I think about it, right? So Research is really about creating new knowledge, right? New understanding, new knowledge, and so on. But when you think of technology research and you think of use-inspired research, there is also ways of applying that in new ways, right? So the knowledge may be known, but applying that known knowledge in a new problem or new domain is itself an interesting problem, right? So I think both these are important. Now, if I know most of you are young, but if you've been in academia and academic circles for a while, there's always this debate, even within departments, of I'm doing sort of fundamental research versus someone else is doing basic research, doing applied research, and there is this basic versus applied tension, and each side might think of themselves as superior, whatever. But I think it's a false dichotomy, right? And the reason I say that is there is this book, it's a wonderful book called Pasture's Quadrant, that lays out research along these two axes. I should use the mouse here. On the x-axis is it's looking at applied versus basic, and on the y-axis is I think something got cut off here. But anyway, the point is this, right? Basically, there are different quadrants. Niels Bohr, if you have done physics, you remember Bohr's model of the atom and so on, that is fundamental research. There was no application in mind. It is just creating new knowledge. On the bottom right is Edison. He didn't create new knowledge. He just looked at an application, creating a light bulb or whatever else he did, and he really sort of built that. The top right is the interesting space where, Louis Pasteur, pasteurization, all of us have pasteurized milk, so that is really a process that is named after him, was doing fundamental research in bacteriology, right? Understanding, germs and so on. But then he produced very, very useful applied things like vaccines and things like that, right? So that combination of pushing the frontiers of knowledge, but at the same time having interesting use cases, I think is a very interesting space. And so I think personally, and in my own work, I don't see this tension, right? You really want to solve problems and you do fundamental work as well as application. I'll give one other example. This is again a very nice book called The Idea Factory. How many people here have heard of Bell Labs? I know many of you are young, but the old ones probably heard of it. But Bell Labs was a very famous lab, and it's still around, but it's been it's a shell of its it's a fraction of its former self. But the reality is that a lot of technologies we take for granted today, right? Transistors, which is the fundamental building block of all digital computing, lasers, the Unix operating system on which Linux is based, all of that came from Bell Labs, right? Now, there is this myth that Bell Labs really employed a bunch of people and they did whatever they wanted without any expectations, right? Now, if you read this book, the author points out that the green stuff is the myth, right? The myth is that scientists came to the labs in the 1930s and 40s, like almost 80 years ago, just for the good of science, right? Just do interesting science. But the reality, according to the author, is the stuff in yellow, which is that the business of the company, AT&T Bell Labs was part of AT&T, American Telephone and Telegraph, was communications, right? So this is before the internet and so on, right? It is telephone communications. And they wanted to build a long distance network of the highest quality and largest range, right? So, initially spanning the US, which itself is a large country, and then, going beyond. And so their job was really to make that application better communication. In the process of doing that, they said, they need better amplifiers. They need, a better theory of even communication, sort of what is possible, transmission. And then a lot of science happened, right? So it was really inspired by this application, which is better communication. So anyway, I'm just sort of making the point. Again, this is a biased view. It's my view, which is that having a driving application can really help you focus and sort of figure out what hard problem to solve. Okay, so now let's we have talked about research, so now let's talk about what is impact, right? Again, I don't think there's a definition of impact, but here's a definition that I actually presented as part of a talk about 8 years ago, 7 or 8 years ago at IIT Delhi. I'll just play the video and you can tell me whether you agree or not. But today, with this connected world, sitting here in the computer science department in Delhi, you should aspire to do work that people on the other side of the globe, maybe California or in South Africa, are talking about in a room. And these are people who don't know about you, but they have read your paper, they have downloaded your software, they have seen a blog by you, and they're talking about it. I mean, that is something that I think each one of you can aspire to do. So anyway, so I think in a nutshell, in my view, if you do something that's so good or so interesting that other people want to copy it, they want to, whether it's your paper or software or a framework, whatever, they want to copy it. I mean, that is impact. Right now, there are other ways of having impact as well, but I think that applies universally, right? It doesn't have to be just research. Even let's say you're an administrator, you come with a new way of organizing the city or whatever, and other cities copy it, well, you've had impact, right? So I think that is something that I think all of us should aspire to do. Now, it's not like you can plan for it and happen, but if you think along those lines, you will create things that, chances are will have that kind of value, right? Okay, anyway, so with that as high-level context, I'm going to talk through about 4 or 5 things during this talk, different applications and different examples drawn from experience. Much of it is work of my colleagues. I had nothing to do with. The first one I had something to do with, but the rest are work of my colleagues. But as we talk, the idea is partly to tell you about those particular applications, but a lot of it is to go back and connect to those themes I mentioned, right, and try to understand sort of how those played out in these examples. So the first one is on road safety. Now, again, talking about sort of being inspired by an application. I mean, I was in the US for many years, about 14 years, and then I moved back to India. And one of the first things that literally hits you, right, is traffic, right, because of the chaos of the roads. And the sad reality is that India's road statistics are road safety statistics are extremely stark. And it's across the country. Some states are. I don't know how Gujarat is doing. Maybe it is actually slightly better. Blue is better, I think. Yeah, the blue is slightly better than yellow, so it is slightly safer, I guess. But it is some years old. The other WHO, the World Health Organization, has listed road fatalities in the top 10 causes of fatality globally, right? So there is heart disease and other diseases, HIV and so on, and then there is road injury, right? So it is a public health issue. Now, again, the WHO has come up with various studies, and they talk about some of the key risk factors, things that you would expect, speeding, drinking and driving, being distracted, and so on. So then you might wonder, well, how about self-driving vehicles, right? Everyone's talking about it. They've been talking about it for many years now. Mr. Musk talks about it quite a bit. Would that solve the problem, right? I think, well, there is a reality in India, which is that it is going to be a while, given that the heterogeneity of traffic and, the flow of traffic and, vehicles and so on. But even globally, the projection is that it will be several decades before the sales of vehicles are dominated by self-driving, and then several more decades before the vehicles on the road are mostly self-driving, right? So I think it is going to be a long transition. So what that means is that, it will be a while before drivers disappear. So if you think about this problem of road safety, it makes sense to think of the driver, because most of the risk factors listed at the top center around the driver. So back in 2007, soon after I returned to India, we had a project that, as I said, we were inspired by this because that's the problem that you see sort of at your doorstep or, every day. And this goes back to my point, problems are everywhere, right? So you have to really find motivation in things that you see. We said, smartphones were relatively new then, and this is what the smartphone of that era looked like. I think the iPhone just came out in 2007, but we were working with what was a fairly leading edge thing, a HP iPac. And we said, okay, can we use these to monitor traffic and driving and drivers and so on, right? So that was the idea. But the reality was that these phones had nothing in them, right? They had no sensor. So even an accelerometer had to be attached externally. So we took an external accelerometer and attached it through Bluetooth to this thing because it did not have anything in the package. It had no camera, it had a microphone because it's a phone, but it had no camera or any of the other sensors. But anyway, we built a system called Dericel. And over the years, the work has been very influential. So we won a couple of Test of Time awards. So Test of Time awards are given for papers that were published usually a decade or more ago that have had a lot of influence on the research community or even broader community, right? So in the case of this work, this idea of smartphone-based insurance telematics, that you use a smartphone to monitor how they're driving and so on, and tying that to insurance has taken off in a big way in the West, at least, right? Not so much in India because of various reasons. And so in some sense, the ideas at some level have manifested in a commercial form there. But our own story here was, one is, of course, we were very early. We were working with hardware that was not capable. But I think we made a more fundamental mistake, which is that we forgot about the humans. So we said, oh, no, we are technologists. Let's focus on automating everything to the extent possible, attaching sensors and coming up with algorithms and so on, right? But meanwhile, around the same time, actually a few years later, maybe you've heard of this company called Waze. How many people have heard of Waze? Yeah, I think it was an Israeli company that was then bought by Google 12 or 13 years ago for $1 billion, and they were doing traffic monitoring broadly, right? The key insight they had was to have the humans in the loop, right? So humans could sort of send messages saying, hey, there is there's a congestion here, or there is usually a speed trap, right? At least in Western countries, there are police people set up in particular locations with a speed gun monitoring vehicles. So they will just quickly share which GPS it gets tagged, so then other drivers get alerted, right? So they use technology, but they also had humans as part of the system, which we had completely steered clear of, right? Because we were saying, oh, we have technology, we just focus on this, right? Anyway, the way we console ourselves is that we beat them to a paper. They got $1 billion, but we beat them to a paper, right? So anyway, that's a small consolation. But again, it goes back to the point. When you think about a problem, think about it holistically, and there'll be other examples of human as well I'll talk about. And don't just sort of focus on a narrow piece and then make choices that are not ideal from the big picture viewpoint. But anyway, coming back to our main context, so we talked about the phone, the lack of sensors and so on, right? Now let's go back to these risk factors again. Think of speeding, right? All of us. Sorry, you think of speeding, right? Today you can get speed with your GPS-enabled phone, right? Is there a problem with that? Like, think of road safety. Maybe think about road safety here, and speeding is a risk factor. The GPS on my GPS of my phone in my pocket can get me speed. Is that good enough, or is that a problem? Any thoughts? So let's say I'm on a road where the speed limit is 80 kilometers an hour. And the GPS tells me the speed is, I'm going at 90 or 100. Is that a problem, like from a safety viewpoint? It is. I mean, it's somewhat of a problem. But let me just play this video, right? So this video is from like a 3 a.m. trip to the airport in Bangalore, on the only high-speed road we have in Bangalore. We went to the airport. And you can just listen to the audio, then I'll talk about it.
Overspeeding alert, please slow down.
Yeah, so it said overspeeding alert, please slow down, right? I don't know if you heard that system say that, right? Now the driver's complaint to me was, look, it's an empty road. It's 2 a.m. or 3 a.m. Everyone else is going at whatever, 90, 100 kilometers an hour. Because I've crossed 80, this thing is constantly bugging me. I mean, sometimes they just unplug it or whatever, or they get very irritated. The point is context matters. It's not your absolute speed. It is relative to what your surroundings are doing, right? If everyone's going at 100 kilometers an hour, it's perhaps safer to go at 100 than to go at 80 and then get hit from behind, right? Of course, there's a limit, like everyone's going, don't keep going, but my point is that context matters, right? I'll give you another example. Distracted driving. Again, those of us drive, I mean, sometimes we do that, we are on the phone and all that, we should not do it, but we might do it, right? Again, there, now that you have had this example, if I, so the way the applications do today, like, in fact, even Nericel we did, is that you have an accelerometer. In our case, we attach it externally. You can detect things like sharp braking, right? Those are considered unsafe events. Do you see a problem? Bad? Again, context matters, right? because they were on the phone, distracted? Or did they brake sharply because someone jumped in front of the vehicle and they had to brake? Otherwise, something bad would have happened, right? So you need to know what's going on with the driver as well as what's going on in front, right? Like if they were tailgating and not maintaining a safe distance, yes, that's bad. But if you're doing fine and suddenly someone did something crazy and cut in, and the driver could not have anticipated, then you should not blame the driver. The driver did the right thing by braking sharply, right? So again, if you have just a Nericel style or Nericel inspired smartphone based telematics thing that is just looking at the accelerometer signal, it will say things are bad, right? Anyway, I think I already spoke through my next slide, so I didn't need this slide. Sorry, I should have done it in this slide. So what's missing? This is where I was supposed to ask those questions. But anyway, so what is missing is really the driver and driving context, right? If you just have an accelerometer and so on, which is what we had in Nericel, and this is what a lot of the applications do today. So that was the genesis of the HAMS project. It stands for Harnessing Automobiles for Safety. The idea is a fancy name, but basically the idea was the smartphone that's on the windshield or the dashboard is like a virtual harness. And we were thinking of fleets. So you have a fleet of 100 vehicles or 500 trucks. As a fleet operator, how do you maintain control over what's happening? So it's like a virtual harness, like it's like things that allows you to control the vehicles as the operator. And the idea was to essentially build a smartphone-based system because, again, from a very practical viewpoint, it is much easier to retrofit the existing installed base of vehicles than to wait for those vehicles to be upgraded to, connected vehicles with fancy sensors over, right? So again, when you think of the big picture, it's sort of an obvious choice. We wanted to do the processing at the edge itself, on the smartphone itself, both because you may not have connectivity depending on where you're driving, but also because of reasons like privacy, right? Because you're collecting data, including of the driver and so on. You may not want to just send the raw data to the cloud. And then we looked at multiple applications, and I'll talk about that story a bit later. So if you take the previous picture of GPS and accelerometer or inertial sensors, now you've added the front camera that's looking at the driver and the back camera that's looking out to the front, right? So you have more context on what's happening. So that's really the key innovation. So smartphones in 2016, 10 years after our Nericel work, had all these sensors, plus they had the processing capability to run simple AI models to do this processing on the phone. So in building the system, in particular being able to run it locally on the device and run it robustly and so on, we had to deal with a bunch of challenges. I will just talk about one of them here, and there are papers on this. If you're interested, you can take a look. This idea of auto calibration, right? And this idea of gaze tracking. So again, these are all. So let me just skip this. I'll come back to this one here, right? Okay, so what we're trying to do is to figure out where the driver is looking. And it is important because when you think of safe driving, again, let's say you're looking straight. Your road is there, you're looking at it. Is that a good thing? What should you do as a driver? How many of you drive here? Quite a few, right, good. What are you supposed to do as a driver? Yeah, have situational awareness, right? You need to know what's coming and what's on the side, and you use mirrors for that, right? So this idea of mirror scanning, right? As I'll talk later, we worked with Maruti Suzuki on this project as a partner, and that was wonderful because they brought in a lot of these real-world insights on what matters when you are testing drivers for safe driving and so on. And mirror scanning was one of the things they said is important. So then the idea was, okay, well, we have this camera, so we should be able to figure it out. So there are all these models that will take a human face and look at a bunch of landmarks on the face based on which, based on the configuration of the landmark, then you can figure out the orientation of the face, right? We had to do some optimization because again, we're trying to do the compute on the device and we're not trying to figure out all the emotional states of the user. So we didn't need the full set of landmarks. We just need to figure out the orientation of the face, right? So we were able to thin it down from 68 landmarks to about 22, saving a bunch of compute costs. But there were challenges, right? The challenges are, first is, where you're looking is a function of both the head pose, how your head is, but also your eye position, right? You could be looking, your head could be straight, but you could be looking that way. Or you could be turning your head, or you could be doing a combination, right? So you need to combine these two. The second is, as I said, we are trying to retrofit a vehicle with a smartphone. Each time you put the smartphone, its orientation could be a little different. It could be tilted, turned, it could be this way, that way, right? So the orientation is different. And even if the orientation would not change, it was, let's say, fixed to the vehicle somehow, the driver could be different, right? If it's a short driver, they could be sitting in, they would pull up this, they slide the seat forward. If it's a tall driver, they would just slide the seat backward. Now, the angles that you need to turn your head and so on would change depending on how you're seated, right? Because it's simple geometry, right? So we needed the system to figure out all these things automatically, right? Because we can't do an expensive calibration step for each time you put the phone in the vehicle and each driver, right? Because that's just not going to work. It has to figure things out automatically. So the first step is how do we incorporate eye state in addition to the head pose, right? Head pose you get from these landmarks. And so, we, again, there's a paper that will discuss the details, but very, very high level, we took the landmarks, figured out the yaw and the pitch, right? So pitch is sort of up and down of your face and yaw is left, right of your face. There's also roll, but we didn't look at that because usually, I guess people don't do that while driving. But yaw and pitch. And then we identified the eye region of interest, did a spatial transformation to account for errors, and then we combined all this with a very simple, I think it was like 5-layer neural network. That gave us a composite or a corrected yaw and pitch that combined both the head pose as well as the eye position, right? So anyway, so that was the combination, but then we need to do this auto calibration, tall driver, short driver. The phone today is in a small compact car, tomorrow it's in a large vehicle, vehicle geometry is different and so on, right? So there the simple observation was the following, right? As people start driving the vehicle and you look at their different gaze directions, again gaze is a combination of head pose and eye position. Where do you think most of the time the gaze will be? Anyone? There's no right, huh? Yeah, so directly in front, right? So straight. And then there are these mirrors. There is usually the right wing mirror and then maybe the left wing mirror or the center mirror or whatever, right? You will expect that if you were to look at a time series, gaze versus time, and were to do clustering, clusters would naturally form corresponding to straight, maybe your right mirror and your left mirror, or if you have multiple mirrors, it will be multiple, right? And then of course there will be other times like something interesting happening on the road there, they will look there too, but that is unlikely to be a significant cluster. So the idea was that we can automatically within a few minutes of a drive, figure out where those clusters are and figure out what angle corresponds, what angle of yaw and pitch corresponds to right mirror, left mirror and so on for that driver in that vehicle for that particular mounting of the phone. And then from that point on, you can do a much better job of figuring out the correct classification, right? So it's really sort of auto-calibrating the classifier, so to say, right? So that's sort of a very simple idea that worked quite nicely. So let me show this in action. So this is a mirror scanning application. So the driver is looking straight and it just looks at how many seconds passed since the last mirror scan. And as part of the driver test, if, or the Maruti's test, it's not the standard test, if more than, I don't know, 15, 20 seconds pass and the driver has not looked at the mirror, that's considered not good, right? And the driver will be notified, right? So that is really the idea. So we actually tried this at Maruti first. So IDTR is Institute for Driving and Traffic Research. I don't know whether there is one here, but Maruti has these institutes as part of their CSR program to promote safe driving, right? It's a very nice thing, and again, purely a matter of chance. I talked about partners and collaborators. With the HAMS project, we would not have had the success we have had without them, right? And I just happened to find them because I went to a Microsoft sales meeting and somehow someone pointed me to them. Yeah, there were some Maruti business people there and they said, oh, if you talk to IDTR, which is their CSR arm, and then that connection happened, right? So it was really a matter of chance. So I would say the lesson there is, if you're doing great work, please talk about it to others. Because you never know when you will find a connection, right? If you just focus on, doing your work in the lab and telling just your colleagues, you will miss out potentially on these opportunities. Anyway, so we worked with Maruti on testing this. I'll not bore you with all the details. we did a bunch of sessions where our system figured out automatically for short clips whether the driver was doing appropriate mirror scanning or not. And the instructors, the expert instructors, also manually then graded those, right? They were grading our system, checking whether, let's say in a clip we say, oh, the driver was doing a good job of mirror scanning, or they were not doing a good job. The expert would then say, is that so or not, right? Or actually they would, I think, give it a star rating from 1 star to 5 star. And so most of our ratings were 4 star or 5 star. Of course, there were some cases where we, didn't do great. There were some false positives. So, but the takeaway is that we did pretty well, and combining the head pose and eye position gives you significantly better accuracy than just head pose. So that's to be expected. Okay, so now let's sort of switch gears to the application, right? So many of you said you drive, right? So I presume you have a license, right? That's how you drive. How did you get your license? What did you have to do? Driver test. Did everyone take a test? Okay, you're a good group, yeah. I took a test, by the way, maybe 35 years ago when I got my license. Okay, he's on record also. So the reality is that in India, at least, I mean, a lot of people get a test, get a license without taking a test, right? And there are many reasons. And this is an estimate, and who knows what the actual number is, but about half or more than half. It's slow and tedious, it's subjective, and shortcuts, and there is a lot of other vested interest in how the testing system works, right? Look at this as an application for AMS. And that whole thing happened completely serendipitously. One is, of course, the Maruti connection, I already told you, right? Now, thanks to the Maruti connection, and Maruti being in the business that they're in, they're very well connected with the government, Ministry of Road Transport and Highways, and ministries like that. So in 2018, there's a conference, Mobicom, were you there? Mobicom? Yeah. In the center of Delhi, about 5 minutes or 10 minutes away was this Ministry of Road Transport building. Through Maruti, we got a 15-minute appointment with the senior bureaucrat, Joint Secretary. We went there, we thought, okay, we'll just tell him what we're doing and spend 15 minutes and come back to the conference. It became a 2-hour meeting because he just looked at the thing and said, oh, this is very interesting. I want to know more. He canceled some other meetings. He gave us 2 hours and he made one phone call to Dehradun and one phone call to Pune, right? Okay, I'll get to the Dehradun one in a few, right? So Dehradun was the local transport secretary. Pune is where they have what's called the CIRT, Central Institute for Road Transport, I think, right? And they do a lot of work on certifying road transport related things for the country. And so just gentlemen, the fact that just by chance, he liked what he heard, he took an interest, he made these connections. And then I'll talk about what happened with Dehradun. So now the government has realized that shortcuts are being taken and things are not good. And so there is this notion of smart RTOs that, RTOs with, sensors and so on. So for example, this here has 2 kinds of sensors. It's got these tall poles. At the top of the pole is a camera that's looking down to the track. And then along the side of the track are these bollards, which if you hit them, there's a little accelerometer sensor with wireless that will report that contact was made, right? So now we're talking about testing drivers. What issues do you see with a system like this? Or is this good enough? Yeah, good. Very good, thank you. One is you have no idea who's taking the test. And then of course things like mirror scanning I talked about, right? What's happening inside the vehicle. Basically you don't know what's happening inside the vehicle. And cost. So back then we were told, like this is several years ago, that about 15 of these poles with a camera on top cost 60 or 70 lakhs. Right? Just the civil works of putting up the fancy camera and all that, right? A lot of money and you still don't get coverage. So that's why I think this gentleman liked what we were talking about. We're saying we're going to put a smartphone. We don't need any of this stuff. We have a view inside the vehicle. So not only we can do mirror scanning and so on, but we can do the basic stuff, which is the person taking the test the same as the one you're giving the license to, right? That detail matters, right? The other thing is portability, right? So in principle, you can even take this on the road, right? So the testing doesn't have to be confined to just the track. You can even go on the road. So anyway, these are all advantages. But ultimately, so although we had this smartphone here on the windshield, we set up a edge server for compute. And the reason was simple. When you run all this heavy processing with both the front and the back camera on the phone, and in Indian summer, this is what happens to your phone. It overheats and shuts down, right? And this was happening rather frequently, right? Because the device just it's not meant for front and camera being used simultaneously and doing all the heavy processing. And so we had a server at the site itself to do the processing. So, often we talk about trade-offs. Oh, you went with the cheaper solution, so you must have given up something. I would argue in this case, we went with the cheaper solution and we did better because we got better coverage, right? So we could do everything that the expensive system did for a fraction of the cost. So again, if you think about a problem domain carefully, you might be able to actually come out ahead on all fronts. Sometimes there's a trade-off. I'm not saying in every case, but I think, thinking about it holistically is good. The other benefit here, I've not mentioned it here, is just privacy, right? So one concern with the camera-based system, which is why I think a lot of insurance companies don't do this, is privacy, right? If looking at the driver all the time, they won't like it. But the advantage for the driver testing thing is it's a very confined thing. It's happening for 15 minutes, and you're being tested, so you're probably fine with it. And after that, you get your license. The system doesn't bother you, right? So I think that's the other advantage from a deployment viewpoint. So anyway, so we launched this in Dehradun. So that phone call in 2018, I think November of 2018, really made a difference. The transport secretary there, Shailesh Baguli, the gentleman in Morth was Abhay Damle, and then Shailesh Baguli was the Secretary of Transport in Dehradun then, in Uttarakhand. He again was very forward-looking. He said, let's make it happen, right? And we went live about 6 months later. Today, this number is off. It's actually 36. I'll fix this later. So today we are live in 36 RTOs, shown in green, and a bunch of others in the pipeline. About 2.5 lakh tests have happened using our system so far. And the user feedback has been very positive, right? And even from people who failed the test. In fact, people who failed the test say, look, the computer failed me, so I trust it. If a human had failed them, they would feel that the human was biased and the human didn't like their, didn't like something, right? Whereas being failed by a piece of technology somehow was good. There were also very unanticipated benefits, right? This we could not have anticipated. We launched in 2019, July or so, and then the pandemic happened. Of course, everything shut down. But as the pandemic started receding, testing resumed. But no driver and inspector wanted to be sitting with each other in the vehicle, right? Because of obvious reasons. And so a system like ours with just a phone and the driver and nothing else was very nice. As I mentioned, none of this would have been possible without partnerships with the government, with Maruti, IDTR, as well as Softex. So Softex is a very small company in Hyderabad that we found through Maruti. And they are in the business of building software solutions for RTOs. So we've essentially enabled them with HAMS technology, right? We just gave it to them for no cost. We said, take it and run with it. And all the scaling that's happening, when we went from 1 RTO to 36, is thanks to them, right? So again, it's really the power of partnerships and collaboration. And then, we open source software, we collaborate with universities and so on. This system won the Chief Minister's Award in Uttarakhand. The Transport Secretary and his team then received the award. It also made the shortlist for the Prime Minister's Award, by some ministry. We didn't get the award, but there's a coffee table book if you're interested. It's called Innovations, New Heights. I'm happy to share a link later, where they feature projects across different societal impact domains, and one of them is this project. Also, there's interest beyond India, right? We routinely get inquiries from various corners of the world. Just yesterday, I got an email from the Philippines. Someone's looking at HAMS, and they want the software, they want technology. Essentially, there is a lot of interest, right? So here's an example where we started with essentially like a mixed kind of thing 15 years ago, 2007, we built Nericell. Ahead of its time, the hardware was not ready. We perhaps also went about it the wrong way, ignoring the human and so on. And then several years later, we revisited the problem, right? So I think persistence helps in research, but persistence with breaks. Like if you're not making progress, maybe it's a good idea to take a break and come back when the context has changed. I think we are reasonably happy with the fix we achieved. Oh, I should also mention that beyond testing, this is our CEO, Satya Nadella. He spoke about this in 2020. Let me just play this.
One of the things that we were very thrilled to see is Microsoft Research working locally on driver safety. After all, driver safety and road safety in India is going to be a massive issue. By taking essentially a camera, taking the front-facing camera or the back-facing camera, the accelerometer, so think of it as multiple sensors that are there in any smartphone, and turning it into road safety. So it's sort of, first of all, it can even give you a driver's test, so it can monitor you, but more importantly, it can give you the nudges so that you're driving safely. So that's an AI project. In fact, Ola is looking at that and seeing how if they can scale it out. In fact, use it even as a way for them to decide whether to lease a car to you or not. So we're very excited about how real-world application of AI, using even effectively sensors on a phone, can be so effective.
Yeah, so this is February of 2020, just a month before the pandemic shut down. We were talking to Ola, we did a little pilot with them. And by the way, we have a connection with Ola just because Bhavesh Agarwal was a student of mine at Microsoft Research. Everything was very nicely set up, and then the pandemic hit, right? And their business completely changed, and this thing didn't go through. So in some sense, we were really hoping to go big with Ola, but then that didn't happen. But then many years later, I got this email from this professor at the University of Chicago saying that he had heard about the HAM system from the Punjab government. So one thing about these IAS circles is that you talk to the Uttarakhand secretary, then all their buddies in the other states find out. And so this gentleman found out about a system from the Punjab government. And I didn't know him. I looked him up. He's actually a Nobel laureate in economics from 2019. So if you know Abhijit Banerjee, who won the Nobel Prize, so he was one of the winners at the same time, right? And he made his name in doing randomized control trial for societal applications, poverty alleviation and other applications. So then that has led to an ongoing collaboration, three-way collaboration, where we pulled in Ola. So essentially, we have ham-tested drivers using our system, many of whom go and drive for Ola. Right? So we know what their test performance was, or the fact that they were tested. We may not even know the details, because we may not keep the records, but we know they were tested or not. They go and drive for Ola. So we know what their on-the-road performance is over the next year or 2 years or whatever. And then the team at Chicago, Michael Kramer's team, have techniques for analyzing sort of data of this kind, right? Which is really what, as I said, was his Nobel Prize was based on. And so that's the three-way collaboration, right? And we have some early results that do show that HAM's tested drivers have somewhat higher ratings as Ola drivers and so on. It's not a huge effect, but there is an effect, right? Hopefully we'll have a paper soon that will discuss the details. Okay, so with this I'm going to move to the next project, and the next two will be a little quicker. But any quick questions on this? I have till 10:30, right? Okay, yeah. Okay, that's fine. Yeah, we had a little technical glitch, yeah. Okay, good. Do we need a microphone for it to be recorded? I don't know how it works. Do you have mics? I can hear you, but yeah, maybe people use mics, yeah.
Okay, sir. Sir, I just want to ask what are the different approaches you have gone through for data collection for implementing this project?
So the previous project? The previous one?
Yes, ACM.
Yeah, so I mean, this is easy, right? Basically, as I said, when HAMS is used for testing, it records whether what the driver did, and I didn't show the form here, but it's a detailed record. But for the purpose of the study, we are not going back and looking at the records. We are just saying, did the driver get their test through a HAM system, or did they get it the traditional way, which, as we know in many cases, is no test also, right? So that is the bottom left here. Ola maintains detailed data, like every time you do a ride, you give a rating to the driver, you might give comments. They maintain all that.
Okay, so they are giving direct data, or
No. So Ola, the data stays with Ola.
It is
They're doing the analysis.
publicly available, or
no, it is not publicly available.
Okay.
They're doing the analysis. But if there is interest, I know there was a student I met at IISc several months ago. The student was interested, and I connected him with the same Ola person, and hopefully they're talking now, right? I mean, if you're working in this domain and you can say what you're doing, and if that's of interest to them, they might be very open to collaborating. So I can connect you with the Ola person who is leading this effort, right? Yeah, I hope that answered your question. Okay, good, thanks. Let me move on. So now I'm going to switch gears and talk about healthcare. Yeah, Nipun, go ahead. You want to use the mic again? Or? For recording purposes, that's all. Yeah. I can hear you, but it's just.
Thank you. So I can understand the role of HAMS for testing, but I still do not understand how it will be used for intervention, as in improving the drivers, helping the drivers improve themselves. Or are you, sorry, anticipating any strategies or interventions, or is it as of now just for testing and for?
I mean, testing is what has been scaling. We started with actually the idea of training and intervention and so on. That was the Maruti thing that I talked about earlier, because IDTR is about training drivers and so on. Our philosophy from the beginning has been not to do anything that intervenes in the moment. So, because if you want to intervene in the moment, you have to be very, very sure of what you're doing. Right? Otherwise, you might cause an accident. Right? Our idea always was, at the end of the session or at the end of the drive, give the user feedback. In fact, we built one of the applications we built was give them feedback with video snippets. Hey, this is what you did. You were distracted. You were dozing off, like your eyes were shut. Just make the driver aware of some of their failings, and then hope that over time they will start watching. Right? It was indirect feedback. That's all we did. We never tried to intervene in person. I mean, you can do that. I think some of these self-driving cars could do that, but we were trying to do this with a smartphone. Really basic hardware, right? You will not have the same accuracy and the same reliability. Yeah. So I think that's what it is. Okay, let me switch to healthcare. Yeah.
Hello, sir. Sir, I wanted to
And
know
maybe you can
that.
also say your name and also which institute you're from. I should ask. Go ahead.
Yes, sir. So my name is Utkarsh. I'm from IIT Gandhinagar only, Masters in Data Science for decision making. So, sir, I wanted to know that this system works for two-wheelers or it is only for four-wheelers in Indian specific.
Yeah. I think we only did it for four-wheelers, car-like vehicles, and it was slightly modified then for commercial vehicles, large vehicles. We have ourselves not done two-wheelers, but I think Softex might have done something for two-wheelers. Okay, I mean, I see the other thing is, of course, two-wheelers, most of the accidents and fatalities probably happen to two-wheelers, but that happens because some larger vehicle hit them, right? So I think if you make the larger vehicles drive more safely, like the buses and the cars, even the two-wheelers will benefit indirectly, right? So, okay, so let's move to healthcare. I'm going to talk about the work of some of my colleagues here, and I think Mohit Jain is coming, right, to speak. Yeah, so he will do much more detailed treatment. So I don't want to sort of steal the thunder here, but I'll just give you a high-level thing, right? So if you look at access to healthcare in India, it's certainly getting better, but it's still constrained by two things, right? One, of specialized equipment for diagnostics, so on. So some large hospitals in large cities might have it, but then you can't deploy this in every village and every town. The second is availability of expertise. The doctor to patient ratio in India is quite low, right? 7.3 doctors for every 10,000 patients. I don't know what the ideal WHO again specifies some number, but it is well below what is ideal. And India's rank is 134th out of 197 countries. So the question is, what can you do about this? So you want to address the cost issue or the access to expertise issue, but you want to still ensure accuracy, right? You don't want to say, oh, you're going to do something, but then the quality of the healthcare goes down significantly. You don't want that. The idea is twofold. Again, commodity devices like smartphones instead of those big machines, and use software intelligence to augment their capabilities. And secondly, to combine AI or technology with humans as part of the workflow. Right, and I will talk about an example of each. So the first project I'm going to talk about briefly is something called Smart KC, which is work of Mohit and his collaborators, and he will tell you, I'm sure, a lot more about this. It's about a disease called keratoconus. It's a disease of the cornea, where a healthy cornea that's shown in the left has a dome shape. In keratoconus, it becomes conical in shape. And it can cause partial blindness or even total blindness, depending on how severe it is. It turns out that the prevalence in India is significantly higher than the global average. because of both genetics as well as the weather and environment and so on, right? Now, how do you diagnose this? There are two extremes. One is a completely manual approach where a healthcare worker uses what's called a placido disc. This disc with these concentric circles is held in front of the patient's eye, and those concentric discs then project images of circles on the cornea. The human then makes a judgment whether those things look circular or they look distorted. If they are circular, that's good. If they look distorted, that means the shape of the cornea has been distorted. Right? What do you see as a problem with this approach? Exactly. You need expertise, right? So I said you don't have expertise. Maybe the person is not a doctor, but still that person has to be expert enough to be able to do this. There's a second issue as well, which is that, so this is an example, sorry, I should have clicked here, where you can see the second picture, the bottom right, these are more vertically oriented, right? So there's a distortion there. Yeah, so it is inexpensive, that's good, but then you don't have expertise. Also, you don't get a digital record automatically, then someone has then write it down or take pictures or whatever, right? So it just sort of makes the process. At the other extreme are these corneal topographers, which are these fancy machines that don't require a doctor or any specialist, that give you a digital record, but they're expensive, right? Thousands of dollars or lakhs of rupees. So that's where Smart KC comes in. It is really a low-cost portable topographer which captures these Meyer images. So this circles are called Meyer images, and then outputs a curvature map, which is really what you want to know, the shape of the cornea. The way it works is that you take a smartphone and you just have a 3-pin attachment here. This thing here contains, and then at the end of it is a LED array to project light. As simple as that. And the rest of the processing happens on the smartphone. So you take the image, it has a way of figuring out whether it's properly centered. If it's not centered, it will give feedback saying, hey, hold it this way, hold it that way. So you sort of hold it correctly, take the image, process it, and you get a heat map. The heat map, I think the red corresponds to steep curvature, and I forget the details, but basically the heat map gives you a sense of the curvature. So what you see here is the left 2 columns is a set of images from the expensive machine, the corneal topographer. And the right 2 columns is the images produced using Smart KC, using just a smartphone with a very, very inexpensive attachment. There's more detailed studies, but sort of visually you can see that the images have a similarity. I don't know whether they actually correspond to the same. I hope they do. Some of the images look different. Anyway, there's a details here, but basically they have done a study to find that the accuracy is pretty good, right? Now, as Microsoft Research, we just open sourced it, just like we did with HAMS. We just open sourced it. In that case, I mentioned Softex that's scaling it up. In this case, a company called Remedio, which is a small startup, got very interested, took the technology, and then they turned this Smart KC into a product called InstaKC, which they launched, I think, 2 months ago, which is essentially the same thing, right? I mean, it's obviously manufactured, so it's sort of not just a 3D printed thing, so it's sort of made more robustly, but it's the same principle, right? So again, it's a very new product, so we'll see how it goes. And it's not a Microsoft product, just to be clear, it is their product, but we had open source technology that they picked up and they ran with, right? So that is really an example of building a low-cost solution using a smartphone for sort of a problem that is particularly prevalent in India. The other thing I talked about is expertise. Of course, the previous project also addressed expertise, but in general, with AI, I mean, there are people who talk about AI will replace doctors, right? AI will be your doctor and so on. And yes, with generative AI and these large models, they have captured the world's knowledge in trillions of parameters, and they're able to do very interesting things. So, but then our insight or our approach is really, rather than think of AI replacing humans, it is really to combine humans and AI. And I think there can be a very synergistic relationship. AI can help humans scale. AI can do things automatically, therefore the humans don't have to go through the tedium of doing a lot of work manually. But then humans can help AI be more accurate, right? So if AI hallucinates or does something that is just incorrect, the human can check it and fix it, right? So that is the synergistic relationship between the two. So again, I'm sure Mohit will talk about this in detail, but let me just do a simple example. On the right is the patient and the left is the doctor. So the patient sends a query. So they've had a surgery. The question is, when can I wash my hair after surgery? The bot, through AI, generates an answer. And it's got some knowledge base. It does some retrieval and then essentially generates an answer saying, oh, you can wash your hair after 3 days. But then from a UI viewpoint, we put a red cross here saying this answer is not yet verified by an expert. In parallel, that interaction is sent to a doctor. The doctor, whenever they have a bit of time, looks at it and says, the bot is asking, hey, this was the question, this is the answer I gave, what do you think? Doctor says, no, this is wrong. At which point the patient is told, oh, the answer is invalid, please wait. And then the doctor has taken correction. They don't have to go and edit the answer. In this case, a simple example, maybe they could have edited it, but let's say there's a big thing about a prescription and the doctor just says, in this case, doctor says better to for 2 weeks. There's some short form language and so on, right? With appropriate prompting, you can take that answer or take the doctor's input and automatically correct the original answer to turn it into an answer that says better 2 weeks after surgery, right? So the point is that we are using AI both to generate the answers, but also to make the process of editing it much easier. You don't have to sit and open an editor. You can simply give it a little cue, and then AI is able to make the correction. Once this correction has happened, this corrected answer, or this verified answer rather, becomes part of the knowledge base. So next time a different patient comes and asks the same question, surgery is done, can I shampoo? The bot says, a similar question to hair, and this was the verified answer. Does this answer your question? Right? So essentially, this is the scaling part, right? So now AI has become a little smarter because it's got additional information in its knowledge base, and so it can answer more questions automatically, right? So this basic workflow has been deployed in multiple instances, something called cataract bot, and these numbers might be a bit old, so Mohit, I'm sure, will present the later on across 3 different thousands of patients and thousands of questions answered, and the vast majority of questions, the answer is just yes. It says the answer is good. In a small fraction, the expert has to make a correction, but the correction, as I said, can be done with a very light touch. So that was in the direct healthcare context. This is more community health workers, where there isn't necessarily an expert. It is just a bunch of community health workers, again, exchange information, and here they can even do voting, right? If people of them say, yeah, that answer looks good. Again, just to be clear, if you're in a medical domain, you have to be very careful about being accurate and so on. So, in an appropriate care, right? Yeah, good.
First, I saw that there was about a minute's lag between question answered by the bot and then by the doctor responding.
So in that case, if a patient just does, so perhaps understands it wrong, is
So
that
I think that's a good point. So I think you really need to educate patients on how to use this tool, right? So the red cross that's saying that's just an initial answer, right? It is not verified. So you may not want to act on it if it's going to be seriously. Yes, I mean I think like if you want to be ultra safe, you should not even give the unverified answer. You should just do the verified thing, right? So it really depends on the context and what the stakes are, right? If the stakes are very high, then obviously you want to be very, very careful. Yes. I think the reason for the half-hour lag is that the doctor does this thing whenever the doctor finds free time, right? The doctor is looking at patients and they have like 5 minutes. They can look at WhatsApp, the whole thing through WhatsApp, look at that and verify it. So that could happen, several minutes later or hours later.
So I had another question.
Yeah.
So sometimes I've seen that doctors themselves have varied opinions on the same thing. and I've seen very varied. So in that case, some particular doctor said something, but other doctor could have disagreed.
Yeah,
So
I
then
think
the
it's a good
knowledge base
question
will
from
get
Mohit. I think he has ways of looking at sort of conflicting information and doing something with it.
Okay.
Right? But this is an example of that, right? I was talking about Asha bot. This is a case where there's no doctor. It's really community health workers, many of them, and what are called auxiliary nurse midwives, who are not quite doctors, but they're like, intermediaries who can look at these questions and sort of do majority voting, right? So now you might argue that in a healthcare setting, you don't want to just go with the majority voting, but express a simple idea of combining humans with AI and sort of having AI produce answers that the human can then correct with very light touch, that gets added to the knowledge base, and all the communication happens with WhatsApp. Whole thing has been packaged to an open source framework called Bring Your Own Expert Bots, right? Where the expert could be a doctor, it could be a nurse, it could be a lawyer, nothing to do with healthcare, right? You could apply it in a legal context, in some other context as well, right? So if you're interested, you can look this up and play with it. Okay, any other questions about health? Yeah, maybe you should use the mic. And also, please introduce yourself.
Hello, my name is Vaibhav. I'm a master's student from IIT Kanpur. So my question is, when there was a delay in that response, so essentially you're waiting for a human doctor, right? So essentially we are making a database out of it and the agents get updated on its memory, right?
I'm sorry, you're being a database and what?
So essentially we are just maintaining a vector database. Is that so?
Correct. Yeah, so the knowledge base is a vector
Okay.
database. That's correct, yes.
So human is still in the loop and that verified answer is by a human doctor, right?
Correct. And once, like I showed in the second example. Okay, so let's move to the third example here. This is, yes. Oh, sorry, go ahead.
Hello, sir. Myself Diksha. I'm from NIT Goa. Sir, in that bot, why did we consider giving an answer and then put verified by the doctor? At the place of that, we can just write, wait till the doctor verifies, other than giving an answer.
Yeah, no, I think that's a great question, and I think Mohit will talk about other examples where we will do exactly what you're talking about. I think it depends on your judgment of what the context is, right? In some context, maybe it's okay to give an initial answer just because the user has something to work with. But if the stakes are high, you would not want to do that. We would want to do exactly what he said, right? So I think he has an oncology bot, which is about cancer treatment, where he takes this exactly approach you're saying, which is no answer will be given until it's been verified, right?
Thank you.
Okay, we'll take one last question, then move on. Yeah. There.
Hello, sir. I'm Sampreet and I'm from PVPSIT in Andhra Pradesh. I have a question about this Dilbot, sir. The question was, is it type of a follow-up conversation with the doctor where the doctor is aware of the conditions of the patient because the advices vary from patient to patient, right?
Absolutely, yeah. So I think this kind of thing is used only for basic questions, right? Patient-specific things will not, you can't just sort of give a generic answer, right? So this is like for basic information. It's like today a hospital will send you home with a little slip saying, okay, here are some instructions, do's and don'ts, right? So this is like think of it as a way of doing a smart version of do's and don'ts, where you can ask your question and in any way you want to get an answer rather than just get a printed slip. Right? Okay, let's move on. So the third and last vertical I'm going to talk about is education. Again, this is work of my colleagues Tanuja and Akshay here and many other collaborators. So, it's very similar to the previous example, of course, different domain. Just like doctors are overworked or healthcare workers are overworked, teachers in India are also overworked, right? They're dealing with large classes, high teaching load, diversity of students in class, right? So, no two students are the same in terms of their, aptitude and, and so on. So a key issue for them is how to generate engaging content that is also contextual. And I'll explain in a couple of slides what I mean by contextual, right? So that students can have the best learning experience. And especially we were focusing at the school level where students are young, and so they need that extra help from the teacher, right? They're not going to sort of necessarily be able to help themselves as much. So for that purpose, we created this thing called the Shiksha Copilot, aimed at teachers, right? So when I say Copilot, I mean an AI Copilot. So essentially using AI to augment the teacher. Now, we deliberately chose to focus on teachers for two reasons. One is that it gives us amplification, right? So if you help one teacher, in essence, you're helping 100 students because that teacher then teaches 100 students. So if that teacher becomes more effective, 100 students can benefit. It's just like in the healthcare setting, right? You help a healthcare worker, they go and touch 1,000 patients, right? So then 1,000 patients benefit. So in some cases, targeting the intermediary can provide you a lot of amplification in terms of impact. The second is having that trained intermediary also helps, just like in the healthcare case, where AI, for example, produces answers that are not exactly what you want, right? Hallucination and so on, right? Because the teacher presumably knows their subject, so they can sort of figure out, oh, that was wrong, let me ignore that. And whereas if you just give it directly to the students and they get something that is incorrect, they might learn the wrong thing. Right? Again, I'm not saying student using AI is bad. I mean, clearly people are doing that. I'm just saying this is a different point in the design space, focusing on teachers, and it's got some advantages. So I talked about contextualization, right? Now, yes, if you think of a subject like maths or science or language or whatever, it should be the same everywhere, right? But then context matters because we are all part of a school system that's got a certain curriculum and there's a certain syllabus. If you start teaching things that are not part of the syllabus, students will get confused, they'll be unhappy and so on, right? So you have to ground your AI in the curriculum. One aspect of that is localization, right? So let's say you have a lesson about nutrition and you use data out on the web, let's say, examples of foods that contain protein. And let's say from the web, it picks up examples that have nothing to do with your local context, right? The kids will see names of food items they have never seen, much less tasted, right? Much less sort of eaten. So you want to sort of localize it. You want to make sure that the context makes sense to students. So for example, in Karnataka, there's some, ragi is a kind of cereal, and you turn that into balls. So that's ragi mudde. It's very nutritious. So that is something that the students, given the context, can relate with. Other such examples, right? So basically, you want that kind of contextualization to happen. Another example of contextualization is just language, right? Depending on your syllabus and so on, you may have your lessons taught in a particular language. So you want to make sure that the answers in that language, right? So these are examples of things that Shiksha tries to enable. So this is a collaboration with the government in Karnataka and Shikshana Foundation, which is an NGO in this space, and Microsoft. We started with a 50 teacher pilot, which went very well. And then late last year, we launched a 1,000 teacher rollout across the state of Karnataka, across all districts. Not all teachers, all districts. So some teachers in every district. And that's also gone well. And now it's going to 8,000 teachers, now not just in Karnataka, but also in Telangana, right? And the Karnataka thing was launched, as I said, several months ago. So let me just play a video and some of the other participants in this relating their experience. Hopefully the audio will work.
Shikshana Foundation started as an NGO that's focused on the education sector. We're working in 6 states across India in about 50,000 schools, impacting nearly 3 million students.
The public school system in India has been severely stressed. We found that typically a teacher handles multi-grade, multi-subjects, especially in the rural areas of the country. The biggest challenge was creating lesson plans.
Preparing those lesson plans, it was taking a lot of time because everything was manual. We were writing and writing and writing.
And that's where I felt technology can help.
Shiksha Co-Pilot is a generative AI solution where we want to empower teachers to create engaging content for their classroom. These teachers are able to generate lesson plans. They're taking the activities that are generated and they're using all of this content in the classroom.
Within 5 minutes or 2 to 3 minutes, I'm preparing the lesson plans.
It's very essential that any solution we roll out supports the local language.
ಟೀಚರ್ಗೇನು ಫ್ರೀಡಮ್ ಇರಲಿಲ್ಲ, ಅದು ಹೇಗಿತ್ತು ನಾವು ಹಾಗೆ ಉಪಯೋಗಿಸ್ಬೇಕಾಯ್ತು. ಆದ್ರೆ ಈಗಿನ ಲೆಸನ್ ಪ್ಲಾನ್ ನ ನಮ್ಮ ನೀಡಿಗೆ ತಕ್ಕಂತೆ ನಾವು ಕ್ರಿಯೇಟ್ ಮಾಡ್ಕೊಳ್ಳಿಕ್ಕೆ ಟೀಚರ್ಗೆ ಫ್ರೀಡಮ್ ಇದೆ.
Shiksha Copilot is based on Azure OpenAI. It's grounded in local context.
ಈ ಮಾಮೂಲಿ ನಾವು ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಪ್ರಯೋಗ ಮಾಡೋದಕ್ಕೂ ಶಿಕ್ಷಾ ಕೋಪೈಲಟ್ ಲೆಸನ್ ಪ್ಲಾನ್ ಅಲ್ಲಿ ಕ್ರಿಯೇಟ್ ಆದಂತ ಹೊಸ ಪ್ರಯೋಗಗಳನ್ನ ಮಾಡಿದಾಗ ಅವ್ರು ತುಂಬಾ ಒಂದು ಖುಷಿ ಪಡ್ತಾರೆ.
The problems that are faced are pretty much universal. So if we have a solution that works in just one state in India, we think that solution can go global.
You know, to me, when I see that video and when I had a chance this morning to meet them, the thing that sort of really inspires me is that combination of folks coming together, right? Which is Microsoft Research India, a non-profit organization, and the teachers all co-designing it together. I mean, when you have that type of feedback loop creating new products, that's magic. And that, I think, is at the end of the day, what we all live for. And it's fantastic to see that.
As you can tell, like anytime you want to advertise a project, we just request our CEO to talk about it, and then people see it. Okay, I'll get to the last bit. I think we're just on time. So, so far I've talked about particular projects, and hopefully you saw the connection to some of the themes I talked about, right? Don't forget the human, the role of serendipity, the things and so on, right? Now I'll talk about what I would call as a cross-cutting issue, which is very briefly about responsible AI. Now, AI is very powerful, but it has to be deployed with care. I think some of the questions about healthcare and so on that some of you asked is an example, right? Like, you have to be very careful about what you deploy because you don't want to cause harm, right? There are particular aspects of responsible AI. I mean, it's a large area with lots of stuff, but there are two aspects in particular that our lab focuses on. One is language, and the other is culture. The reality is that most of the data out of the web is in English, and so most of the training data is in English, and that brings in certain biases. And the general approach of taking the English answer and then translating it doesn't necessarily work very well. So we've been doing how these models actually work. So Karya, I don't know how many people have heard of Karya, but it's a small company that came out of our lab. In fact, they were on the cover of Time magazine a couple of years ago for the work they're doing. They're really about, enabling people with just a smartphone to do digital work, right? In fact, the original name for the project was Digital MNREGA. I had come up with this name many years ago. MNREGA is the government rural employment scheme. So the idea was, can we do a digital version of it? But anyway, so Karya is this company, and dignified digital work. And so we worked with them on having people who are in that context actually evaluate these large language models and see how well they're doing, right? So it's really sort of making sure that the humans are in the loop of evaluation, but not just for language tasks, but also for larger sort of end-to-end use cases, whether it's healthcare or agriculture. A lot of things we talked about, right? Education and so on, and others like finance, legal. How do we ensure that the humans are part of the loop as you evaluate these, right? So if you're interested in this, my colleagues Sunina Sitaram and Kalika Bali, they work a lot on this, and you can look at their work. Okay, this is my second to last slide. So this is back to my theme. So I think we started with this. I hope I've convinced you that there are interesting problems to be seen everywhere, right? And I talked about just a few, but as you go out there, as you step out of this hall or even inside this hall, I'm sure ideas and problems will occur to you, especially if you are interested in this sort of use-inspired research, where you look at a use case, get inspired by it, and then solve the technical problems you need to solve to address that use case. As I said, AI is very powerful. So Shiksha is a great example. Regardless of which state and which curriculum or which grade, it can do its job because all it needs is the textbooks as input or the syllabus as input, and then the AI does the rest. You don't have to write purposeful software for a particular use case. Don't forget the humans. I hope you saw several examples of that. Collaboration, partnership, pretty much every project here, whether it is HAMS or Shiksha or Dilbot or even Smart KC, is in partnership with a startup or the government or an NGO or academia or all of these. And finally, expect surprises, right? I think I gave you an example of HAMS where we didn't expect to be doing this automated driver license testing thing, right? And a chance meeting led to that. Finally, I want to end this with this slide. I've given you a lot of insights, and I did give you this caveat that these are personal views. So let me just emphasize that again. I believe what would help you in this process is self-belief and trust in your own judgment. Don't accept something simply because someone tells you so, even if that someone happens to be on a big stage speaking into a microphone just now. Finally, have a sense of humor. That's because I was trying to make a joke that don't listen to someone who's on stage speaking, which is what I've been doing. I think ultimately, that's very important, right? Like, there is no one right answer here. You have to decide for yourself what makes sense. Just listen to my talk, listen to the next talk, listen to the talk the rest of the week, and decide what makes sense to you. And I'm not giving you the truth or the only way of doing things, right? And no one can. So I think that is extremely important to keep in mind. Thank you. That's all I have. On time, but maybe we can take a few questions if there is interest. Yeah, if there are questions.
Hello, I'm Nupur Asudani. I'm from IIT-GN. I'm a BTech CSE student.
Yeah.
My question is related to the Shiksha AI thing. I have experience teaching for Akanksha, which is one of NYASA's initiative. NYASA is a student-run organization here at IIT-GN, through which we teach students at the Basan and Palaj government schools, which are right nearby. One of the main issues that we face is that the teachers there, they're not regular. The teachers keep changing. And another issue is that because of that, the students, even if they're like 5th grade students, they won't have the basic knowledge that a 3rd grade student should ideally have. What we're trying to do is we're trying to bridge that gap. We teach a few classes a week. And one of the main issues we face is that we won't always have volunteers who have the same language. So if I'm not great at Gujarati, I'll face difficulties teaching the students there. So does Shiksha AI, is there any way that I can reach out to them or get help from them in this regard?
I'm very happy to connect you with Shiksha Foundation is our partner. In fact, actually, I do have a few more slides. I forget. I will actually talk about MSR India. I completely forgot about that. And I can talk a bit, maybe I can sort of answer your question as I talk about this as well. But we are absolutely happy to connect you with them and we can explore whether your use case matters. Our assumption is that there is a teacher who uses the tool. Now, if the teacher themselves is not there, I think it will still help you in terms of just effort involved in creating a lesson plan and so on, right? So let's say you go in with much less effort, you can create content. But if the teacher does not know the language and so on, that's a different ballgame. I don't think this will necessarily help you with that. But I'm happy to, let's take it offline. Let's talk about it. But let me actually just spend a few minutes talking about the lab. So this is Microsoft Research India. Just very quickly, we were set up about 35 years ago globally. There's more than 1,000 people globally across many different countries. We're looking to advance science and technology to benefit humanity. That's a sort of high-level goal. This is Microsoft Research India. We just turned 20 earlier this year. About 60 full-time people, but an equal number of students, what we call as research fellows, as well as postdocs and others. And our people have won various recognitions globally as well as nationally over the years. Broadly, these are the areas we work in. And I think the bottom right, technology and empowerment, is what I talked about quite a bit today, but there are other areas we work in as well. I think I touched on most of this. As part of our work, we engage with the ecosystem We have spun off projects, we work with startups, we work with governments, we work with NGOs, of course with academia and on. And I'll come to your question here. One of the things we have done over the past year is initiatives where we get to work with both startups. So Physics Wala is an example. That's very much in the domain of teaching students, but it's a commercial service. A center or an initiative at IIIT Bangalore, local university, to work on scaling and sustaining societal impact projects, right? So take the output of Microsoft in India and turn that into digital public goods, right? So one of the projects there is Sikshana, with Sikshana Foundation, the same foundation. And so they are going to take this and scale it up. So if I connect you with them, maybe they can take your inputs. And so if you send me email, I can make that connection. And then, yeah, we do engage with academia at multiple levels, to grow the talent pool, to do collaboration and so on. We organize this academic summit. One of it's happening end of this month. I think because of logistics, we have a handful of people coming in person, but a lot of people who can join online. So I think it was on LinkedIn and so on, so you should be able to join if you're interested, or at least register. Collective PhD awards process that we kicked off last year. We're doing it again. Zeal, from your student, won it. I don't know whether Zeal is here. No, not here. Yeah. With other external events, yeah. Okay, and then finally we have this research fellow program. So those of you who are undergrads, if at the end of your bachelor's degree you're interested in exploring research, you can apply to this program. Some students have gone through this program, done extremely well. Many have gone for higher studies. Others have worked with companies like Ola. Others have done spin-offs from the lab. People have done many different things. So I think that's my last slide. Yeah. Okay. Thank you. Sorry, a few extra slides. I forgot about this. But anyway, I think to answer your question, if you're interested, since Sikshana and education is one of the things we're doing with IIIT, we can see if your inputs can sort of inform that discussion. Any other questions? Yeah, go ahead. There's one there and one here. Yeah.
Hello, sir. I'm Tanya. I'm from VIT Vellore. I had a doubt related to Shiksha Copilot. How do we ensure that the data that the Copilot provides is latest? Because usually we train models on data that is older and up to a particular year. So if there's any change and if there's any updates, how do we ensure that the students stay updated with the latest?
Yeah, so essentially the information, the latest information or information from the curriculum and so on is provided as input, right? So it is not part of the model weights, but it is what's called in-context learning, right? So essentially you're providing this as context as part of the prompt. So, that's how, it's like how a lot of other applications also work, right? Essentially you do a web search to get context and then give it to the AI. That's important. So it's no different from that.
Okay. Thank you, sir.
Okay.
Good morning, sir. I am Aparna here, and I'm a student of Bachelor in Technology of Artificial Intelligence and Machine Learning at SIT Pune, Symbiosis. My question was regarding the same project, Shiksha. I happened to volunteer at Doorstep School Foundation in Pune last year, and one concern that a challenge that we faced while volunteering was that there was a discrepancy in understanding of staff, the technological understanding of staff versus the knowledge that we had. So what are your suggestions with...
you meaning students? Students versus staff? Is that what
the technologists, so people who are developing the tools. We were trying to develop an app for them, but they did not understand the constraints or the time that it would take.
Yeah. Okay.
So what would be
I think that's a very important point. So I think not just in the education space, even in the other applications I talked about, healthcare as well as HAMS, it is extremely important to spend time with the actual users of your technology, right? So whether it's Siksha or Dilbot or HAMS, we actually took the trouble, right? We actually went to Dehradun in the HAMS case, for example, and spent time there, because you need to understand their workflow, and you need to understand exactly what is their knowledge or their way of looking at things. So I think there's no substitute to actually spending time with the intended users of your technology.
So the generative AI tool, which is more general, can it be adapted for their particular knowledge or where they stand?
I think prompt engineering, as you know, is very powerful, right? So you can, for example, I mean, nothing to do with our work, but there are things online you can find that say, oh, answer this question as you would explain it to a 6-year-old. Then it can sort of then figure out a way of doing that, right? So I think AI is very powerful, but what I was making a more general point that ultimately, whether it's AI or something else, when you're going to roll it out, if you do it without an understanding of your users, chances are that it will sort of turn out to be less than ideal, right? So,
Thank you.
okay, I don't know how we're doing on time. Maybe 2 more questions and we close it? Or we can do have time? Okay, good, good.
Oh, hello, sir. So basically, I am Aman Prakash. I'm a bachelor student from NIMT Ranchi. So my question is related to that doctor's bot. So whenever a doctor corrects the bot, then how is that reinforced back into the system? Do you use some alignment method or some fine tuning method?
That's a good question. Let me not hazard a guess because I think Mohit is the expert there. But I think if that corrected answer conflicts with something that's in the database, there is some resolution that's done, right, of sort of what the correct answer is. So I think Mohit is the right person. He's going to give a detailed talk later, so he can answer that better.
So Shiksha, health, everything is going smoothly when you get on very good environment. Like then what kind of projects or research is going on related to environment in MSR?
Related to environment?
Yeah, environment, like green energy or air quality, forestry, agriculture kind of things.
So we've had work a few years ago on air quality monitoring, where we were looking at the reliability of sensors. So how do you detect that a sensor has gone bad and be able to reject incorrect information? So there's something called dependable IoT that was done. Akshay Nambi is the person who was leading that work, where we worked with a company called Respirer Systems, which I think is one of the leaders in this space across the country. So that's an example. But on the energy space, there's more recent work on a project called Vasudha, looking at optimizing the operation of renewable energy system, right? So figuring out things like, depending on the price of power in the grid versus what the expected weather and so on, you have to sort of figure out a optimal way of scheduling. When do you draw from the grid? When do you draw from your renewable solar plant and so on? And so as part of Vasudha, they developed a framework called N-Cortex. I think it was open source as well. N-Cortex is a, let's call it a decision support or decision optimization system for renewable energy plants, right? So that's something we have done as well. I don't think we have active projects on that right now. Active projects are more, actually even the road safety stuff is old, right? It's really, Shiksha is active, healthcare is active, and accessibility. So that's another active area. Okay, I think we'll take one last question. Yeah, you come back. I thought you had your hand up as well. You can ask and then maybe you can have the last one. Go ahead.
Good afternoon, sir. Myself, Ruddisha. I am from LD College of Engineering. My question is that most of the projects that you shared, they are use case based. And in majority of them, your verification system is done by users. It is manual. For example, in the Dilbot. But there is this driving one project in which how do you, like, you are using the open face model for identifying what is the change in the facial segment mask, right? So how do you, is the output of the model a bottleneck always, or are there any methods so that you can improve the accuracy of the bottleneck model that you are using for the use case that you want to implement?
We did, as I said, like we did make changes, right? Like for example, as I said, like instead of 68 landmarks, we went with a small number of landmarks. So we did sort of make changes. I don't know what you mean by bottleneck, but I think the one thing I would say is, especially in computer vision, things rarely just work out of the box, right? You have to actually adapt it to your particular use case. And that's pretty much what we did, even with regard to combining eye position and head gaze. We sort of trained a custom model, a small model, to do that combination, right, based on our data. So I think in terms of evaluating how will it work, in that case as well, the users were, when I say users, not the test takers, but the inspectors or RTO people, they looked at the output of our system and made sure it's accurate. And then since it's very accurate, they said, okay, fine, we can go ahead with this, right? So that is required. I mean, you can do AI-based evaluation as well. But then you have to then worry about what I talked about in the last part of my talk, right? Cultural and language biases, right? So if the AI has not seen much data in that context or in that language, can it do a good job of evaluating things, Shiksha-like application in that language, right? So I think having humans as part of your evaluation loop seems to make sense in many cases. So, and think of it as neither human nor AI exclusively, but them working together. Okay, go ahead.
So I'll ask this question on the behalf of students as well as on my behalf. I very often get to work with very ambitious students who want to do everything. So they are interested in multiple projects, multiple internships. And this question keeps coming up, like what do they really care about when they're excited about everything? And then the traditional question, the usual question on breadth versus depth. So I wanted to have your insights on how should young students be thinking about it.
That's a great question. Again, there's no one right answer. I would say I think the way to really be successful in something is to take an end-to-end view, right? Rather than just focus on a slice of the problem. Like think of, okay, what is the bigger problem you're trying to solve? Once you take that view, you will find that even one of your problems is large enough to keep you busy, right? This idea of like doing a little bit here and a little bit there and so on is only feasible if you're doing tiny slices of this problem and that problem, right? And sometimes people do that, and again, nothing wrong with it, but that might give you a paper here or a paper there. But it's unlikely that you will then build something substantial that has the kind of impact I talked about, right? Which is you build something that people from across the world or across the country are looking at it, and people who don't know you, and then they're asking for it, right? So again, there's no one formula, and it's not like you should do only one thing. But in anything you do, take a holistic view, figure out what it takes to solve the whole problem, or at least solve the problem in a way that's sort of meaningful in the bigger scheme of things. And chances are you will find plenty of things to do in one problem itself, or maybe rather than having to sort of spread yourself across many problems, right? So that's really what I would say. Again, there's no hard and fast rule, right? So again, go back to my last slide. What has worked for me may not work for you. Okay, thank you.
Okay, let's thank the speaker again.